everyone. Welcome to the Narayana Group of Schools. My name is Anish Jain and here I am today to discuss the JEE Mains question paper which was held on 27th January 2024 first shift or the morning shift. This is a memory based question paper. So there may be some mistakes in the paper or there may be some corrections later. So let's begin with the first question then. So in the first question, it is given that there are two infinite current carrying wires carrying current I each, and they are carrying current in the opposite directions as shown below. Find the magnetic field at this point P. So what we can do here, you know the magnetic field B is given by mu naught I upon 2 pi r, where r is the distance of the point P from the wire. And in this question it is given 10 centimeter. And if you look at the direction of the current, then the current direction, the field direction at point P is inwards for both the current carrying wires. So I will write the net field B net is equal to the field due to the first wire plus the field due to the second wire. So that means I will write mu naught, and remember they have asked in SI unit, so I have to convert centimeter into meters. So I'll write mu naught I by 2 pi r. R will be replaced with 10 by 100, and I can just multiply it with 2 because both the wires carrying the same current I and the distance also are equal. So from here we will get 10 mu naught I upon pi, which is 2. Okay, let's move to the next question then. So in this question, it is given that the diameter of Earth becomes half, keeping the mass to be constant. So mass is constant, but the diameter has decreased. Obviously, the density has increased. Then what will be the acceleration due to gravity at the Earth's surface? Will it increase, decrease? Let's see. You know that the acceleration due to gravity is equal to gm by r square. That means the acceleration due to gravity is inversely proportional to r square. So I can say now they have because the mass is constant, so that's why I can just say that the acceleration due to gravity depends only on r. Okay, and it is an inverse square relation. So I will just write g initial by g final is equal to r final by r initial whole square. So what will I get here? What will I get here? G initial by G final is equal to, because they have said that the radius has become half. So I will just write 1 by, final radius is half the initial radius. So I will get half square, that is 1 by 4. So that means I will get G final is 4 times G initial. So that means the gravity acceleration due to gravity has become 4 times if I have half the radius or the diameter. Okay, now let's move to the next question. So in the next question it is given that there are two masses. First mass is 4 grams, second mass is 25 grams, and they are having the same kinetic energy. And if they are having the same kinetic energy, they are asking us what will be the ratio of the magnitude of their linear momentum. I know that the linear momentum is equal to root over 2 mk. So because the k is constant, I can say that p of m1 divided by p of m2 will be equal to root over m2 by m1. That's it. So how much will I get? 5 upon 2. Okay. Now they have asked you, okay, just 1 minute. What we have done here, P1, the first mass was 4 grams and not 25 grams. So just correct it here. P1 upon P2 will be equal to root upon 4 by 25. That is 2 by 5. So the correct answer will be 2. Okay, the first mass was 4 grams, and so that's why I've written here first mass is 4 grams. The linear momentum is directly proportional to root m. Clear? Okay, let's move to the next question then. A charge q is equal to 10 raised to power minus 6 coulomb is placed at the origin. So at the origin of the coordinate system, we have one charge whose magnitude is 10 raised to power minus 6 coulomb. Find the potential difference between 2 points A and B whose vectors they have given. So there is one vector somewhere here and this is one vector somewhere here. Now I know that the electric potential is a scalar quantity. So if the electric potential is a scalar quantity, we don't actually need the, there is no direction. So we just need the formula, the magnitude, which is kq by r. The point charge electric potential at any distance r from the point charge is given by kq by small r. All right. Now r is the distance of the point charge from that point, and I can clearly see that the distance of this point from the origin is same as the distance of this point from the origin. So if the distances are equal, that means the potential at this point and this point both are equal. And if the potentials are equal, that means the difference in potential will be 0. So the answer should be 0. Okay. Now let's move to the next question. What is given here? A body of mass 1000 kg is moving horizontally with a velocity of 6 meter per second. Okay, so the body of mass 1000 kg and it is moving horizontally, and what is the speed given? 6 meter per second. Another body of mass 200 kg is added gently. That means this 200 kg mass initially had no velocity. Then what will be the new velocity? So here there is no external force. If I take the 1000 and 200 kg system, there is no external force. So if there is no external force, I can say the momentum of the system is conserved. So if the momentum of the system is conserved, what should I write here? Initial momentum is 1000 into 6 plus 200 into 0, because the 200 kg mass was initially at rest and now it sticks to it. That means the total mass has become 1200 and the velocity is v. So the new velocity v which we need to find out is v equals 1000 multiplied by 6 divided by 1200. So we will get v equals 5 meter per second. Okay, so the answer will be 1. Okay, let's move to the next question then. What is given here? That there is one system of point mass, each mass is 1 kg, okay, and they are for at the vertex of a square. Then find the moment of inertia about the diagonal as shown in the figure. So if I have to find the moment of inertia, I know that I need the perpendicular distance of the point mass from that axis of rotation. Now for this particular mass and this particular mass, these two masses are already on the axis. That means the moment of inertia for this will be 0. The moment of inertia for this also will be 0. And because it's a square, so I can say that the diagonal, these two diagonals are already perpendicular. So the perpendicular distance of this 1 kg from this diagonal will be equal to this half of this diagonal length, and the diagonal length is, because this is 2 meter, this is 2 meter, so I can say the diagonal length is root over 2 square plus 2 square, that is 2 root 2. Okay, that means this length, the perpendicular length, is only half of it, so that's a root 2. So the total moment of inertia is going to be mr square. For this one, mr square is m into root 2 square. Okay, and then I can also say into 2, because for this also the same distance is there, and for this 2 it is 0. So I will get the net moment of inertia as 4. Okay, and the unit obviously is kg meter square. So the answer will be 3. Okay, let's move to the next question then. So what is given in this question? A rod of length L having resistance R is cut into two equal parts. So a rod, and this rod is cut into two equal halves. Now I know that resistance is directly proportional to length and resistance is inversely proportional to area of cross section. Now when you have cut it into two halves or two equal parts, the radius, the area of cross section has not changed. So that's why the resistance here will only depend on L. The length has halved, that means the resistance has also halved. Okay, so that means these two parts individually has R by 2 and R by 2 resistance, but now they are connected in parallel. So when they are connected in parallel, in that case the equivalent resistance will become R by 4. Okay, so the answer will be 3. Let's move to the next question then. In this question it is given that uh, it's a statement based question, so they have given us two statements. Let's read them out. The linear momentum and moment of force. The moment of force basically means the torque, and torque is rate of change of angular momentum, right? Torque is rate of change of angular momentum. Okay, so definitely these two have different dimensions. Let's find the dimensions also. So what is the dimension of linear momentum? So linear momentum is nothing but mass into velocity. Okay, so that means I can say it is mlt minus 1. What is the dimension of torque? So torque is nothing but force multiplied by length. Okay, uh, just dimensions we are finding out. R cross F, R and F. R is the dimension of length, so I will write mlt minus 2 is the dimension of force, and the dimension of L is obviously L. So I will get the dimension of torque as ml square t minus 2. Obviously these two dimensions are unequal, so statement 1 is definitely false. And the second one is, what is the dimension of Planck's constant and angular momentum? So let's find out the dimensions of Planck's constant, and you know that E is equal to HF. E is equal to HF, where H is the Planck's constant, and the unit of energy is ml square t minus 2. And I'm sorry, the dimensions of energy is ml square t minus 2, and the dimensions of Planck's constant we need to find out, and the dimension of frequency is t minus 1. So the dimension of Planck's constant will be ml square t minus 2 into t. If I take it that side, it will become t minus 1. So this is the dimension of Planck's constant. What about the uh, angular momentum? So angular momentum is, if I look at the dimension way, you know, it is mr cross v. I can write just mvr. The dimension of m is capital M. The dimension of velocity is lt minus 1, and the dimension of r is L. So I'll get ml square t minus 1, which is same as the dimension of the Planck's constant. That means the second statement is correct. So the answer should be the statement 1 is false and the statement 2 is correct. Okay. Now let's move to the next question. This one was the simplest, I guess, among all the questions that was asked. In which of the following circuits the diode is a reverse biased? So the diode, if the diode has to be reverse biased, so this is the P side and this is the N side. If the diode has to be reverse biased, in that case the potential on the P side should be less than the potential on the N side. Okay, and for forward bias the potential on the P side is greater than the potential on the N side. So now let's look at the options here. In the first option I can clearly see that the P side is at lower potential compared to the N side. That means definitely this is a reverse bias. If I look at this, the second option, then the P side has higher potential compared to the N side. That means it is a forward bias. Same way, next also I can see it's a forward bias, even next is forward bias. So the answer is only the first option. The first option is the reverse bias, so the answer will be 4. Okay, all right. So now let's proceed to the next question. In this question, it is given that a prism has a refractive index of cot A by 2, where A is the angle of prism. Then what is the minimum deviation due to the prism? So I know that the minimum deviation delta mean is 2I minus A, and the deviation is minimum when I is equal to E. When I is equal to E, the deviation is minimum. But when I is equal to E, R1 is equal to R2 is equal to A by 2. So if I apply Snell's law on the first interface, then I will say this is I, and the angle of refraction here will be A by 2. So I must say 1 into sine I should be equal to mu into sine A by 2. Okay, so now from here we can get the value of I. Okay, and mu is given to you as cot A by 2. So from this mu I will put it here and I will get the value of I, and this I will put here in the equation of delta mean, that is 2I minus A, and finally we will get pi minus 2A. That will be your answer. Okay, you can just put it and you will get the answer. Okay, all right, let's move to the next question. In the next question, it is given that a particle is performing simple harmonic motion and amplitude is given as 4 meter. The speed of the particle at its mean position is 10 meters per second. You know the speed of particle at its mean position, v is equal to omega I. Okay, so they have given us the amplitude, they have given us the speed at the mean position. That means I will get the omega. So the angular frequency of SHM according to this question is 10 upon 4, and that will come out to be 2.5. Find the distance of particle from the mean position where the velocity became 5 meter per second. It's very easy because we know v equal to omega root over a square minus x square. V equal to omega root over a square minus x square. So here I have been asked find the distance when the speed becomes 5 meter per second. So I will just write v as 5, omega as 10 by 4 or 2.5 root over a square. A square, a is given to you as 4, and x I need to find out, and this will become 2, and if I square it I will get 4 is equal to 16 minus x square is equal to 12. That means x is equal to 2 root 3. Okay, let's move to the next question then. So here what is given, find the charge on the capacitor at steady state. You know, at steady state, the capacitor will behave like an open circuit. There will be no charge flowing through the capacitor. So if there is no charge flowing through the capacitor, that means in this question, at steady state, this 1 ohm and 2 ohm, this two will be in series because there is no division of charge here or no division of current here. And similarly, this two will be in series. Now, you also know that in series, the potential divides in the direct ratio of resistance. In series, the potential divides in the direct ratio of resistance. So let's assume that this side we have taken as 0 volt, then this side I can write as 10 volt, this side is 0 volt, and this side is VA, and this side is VB. I need to find VA minus VB so that I can find the charge on the capacitor, because the charge on the capacitor will be 6 microfarad multiplied by VA minus VB. So let's find VA then. So because I know that in these two are in series and the total potential difference here is 10 volts. So this 10 has to be divided between 1 ohm and 2 ohm in the direct ratio of resistance. So that means I will say the VA minus 0, which is the potential difference across this 2 ohm resistor, will be equal to 2 upon 2 plus 1 multiplied by the total potential difference was 10 volt. So I will get 20 by 3. Similarly, here also this 10 volt will be dividing in the direct ratio of resistance. So I must say VB minus 0 will be equal to 4 upon 4 plus 3 into 10, and which can be written as 40 by 7. Clear? So in that case, what will the potential difference VA minus VB? And that will be equal to 20 by 3 minus 40 upon 7. If you take the LCM 21, I will get 20 into 7 is 140 minus 120, that is equal to 20 upon 21. So once I get this, 20 upon 21 is the potential difference, then what will be the charge? The charge is 6 into 20 by 21, and that will be 40 upon 7. Okay, let's move to the next question. In this question, it is given that there is a proton whose velocity is v naught. They have given the vector, not it's the they have given means basically you have to consider it to be a vector, passes through a region having both electric field as well as magnetic field. It is given that the velocity of the proton does not change. The velocity does not change here means the vector does not change. That means it cannot change the direction or the speed or the magnitude, that is the speed. Then which of the following may be true? If E is 0, B is 0. There is no force on the charged particle, and if there is no force on the charged particle, obviously it will continue to move with a constant velocity. So the first one, definitely it is possible. If E is 0 but B is not equal to 0, yes, this is also possible, because if V is parallel to B, then there is no magnetic force, and because there is no electric field, that means there is no electric force also on the proton. That means this case is also possible. What about the next option? E is non-zero but B is 0. Now E is non-zero, that means the particle will definitely have some acceleration. Okay, because F is QE, and this force will act on the charged particle whether the particle is moving in any direction. And if there is a force on the charged particle, it has some acceleration, and if there is some acceleration, the velocity cannot remain constant. So this situation is not possible. And let's look at the next option. If E is not equal to 0 and B is also not equal to 0. Okay, now there can be one case when the force due to electric field and the force due to magnetic field balance each other, which you must have studied in a velocity selector. In a velocity selector, the magnetic field and the electric field are adjusted in a way that the force due to magnetic field on the charged particle and the force due to electric field on the charged particle are equal and opposite. And when this happens, the net force on the charged particle happens to be 0. And if the net force is 0, that means again there is a case, or there may be a case, when in presence of both the electric and magnetic field, the charged particle may move only in a straight line. So this situation is also possible. So then the possible answer is A, B and D, that is the third option. In this question, it is given that a particle has initial velocity of 5 meter per second in the x direction, and it is at origin at this instant. So the particle is at origin and moving towards the x direction with 5 meter per second. Its acceleration is given to you as a constant, which is 3 I cap plus 4 j cap. So there is an acceleration component in the x direction as well as the y direction. When the particle's x coordinate is 16 units, what will be its speed? Okay, so I can use in the x direction v square equals u square plus 2as. So at this instant, v square is equal to u square plus 2as. If I use, then v square equals initial velocity is 5, 2 into acceleration is 3 in the x direction into the displacement is 16. So how much will I get? So that will be equal to v square, and or this is vx actually only in the x direction. So in the x direction, what will be the speed? So I will get uh, so 16 multiplied by 6 is 96, sorry, plus 25. So I will get Vx is equal to root over 6 plus 5, 11, 9, 121. So Vx is equal to 11 meter per second. Okay. So once I get the speed in the x direction, now also I have to find the speed in the y direction. Now to find the speed in the y direction, actually first I need the time when the x coordinate became 16. So for that I might use this relation Vx is equal to ux plus axt. So I will get final velocity is 11 in the x direction. The initial velocity is 5 and the acceleration is 3 into time. So I will get the time as 11 minus 5 is 6 divided by 3. That means the time is 2 seconds. So at 2 seconds, what is the y coordinate? Okay, or y direction speed. Actually, I don't need the coordinate in the y direction. I need only the speed. So what can I do? In the y direction, I will again use this relation Vy is equal to Uy plus Ayt. Now, in the y direction, the initial speed is 0. In the y direction, the initial speed is 0. So I will write Vy is equal to Ay is 4 and T is 2. That means it is 8 meter per second. So what they have asked is, when the particle's x coordinate is 16 units, what is the speed? So that speed will be actually root over Vx square plus Vy square. That will be root over 121 plus 64, and that will come out to be root over 185. Okay, so this is the correct option. All right, let's go to the next question. A spherometer is used to measure. So a spherometer is a device which is used to measure the radius of curvature. Okay, so let's say this is the curvature of a lens that we need to measure. Okay, so this way there are pointers and we measure this distance, and with the help of this distance, the curvature, we measure with the help of geometry the radius. So if this is y, this distance is r minus y, this is r, and let's say the diameter is, so with the help of this distance, we can also get the diameter, and if I know the diameter, I also know the radius of this. Let's say it is small r, and by Pythagoras theorem, we will say capital R square is equal to small r square plus capital R minus y whole square. So this is how we can find the radius of curvature. So a spherometer is used to find the radius of curvature. Okay, let's move to the next question. It is given here that a particle is performing simple harmonic motion, and the equation of simple harmonic motion is given to us. Then they are asking, what is the kinetic energy, potential energy, and speed at a by 2. Okay, I know that V is equal to omega root over a square minus x square. According to question, x is a by 2. So I can say x is a by 2. That means uh, I have just put the value of x square here, and omega uh, from this equation, but also from the spring omega, we can also write this as root over k by m, because they have asked in terms of mass. All right. So I will get V is equal to root over k by m into root 3a by 2. Okay. So this is the answer for velocity. Clear? Now, what about the kinetic energy? Now, once I know the velocity, obviously I know the kinetic energy, half mv square. So that will be equal to half into m into v square. Just square the velocity, 3a square upon 4, cancelled. I will get 3ka square upon 8. So this is the kinetic energy. What is the potential energy in SHM? The potential energy is half k x square. Now x according to question is a by 2. So half k a square upon 4, that is k a square by 8. That means you see all the options are satisfied in the second option, kinetic energy, potential energy, and the velocity also. So the option number 2 is the correct answer. Okay, let's move to the next question. What should be the elevation of outer track of the train to move in a circular path of radius r? It is given the width of the track is w, and the width is very small compared to the radius of curvature, and the speed of the train is v, and we need to neglect friction. So this is a question of the banking of road or the banking of rail lines, whatever they have asked. And because there is no friction, only normal force is providing the centripetal force which is required for the circle. And in fact, there is a component of the normal force which is providing the centripetal force. Okay, and this component of normal will be balanced with the gravity. Okay, and I guess you know the formula, tan theta is equal to v square by rg, where theta here is the banking angle. Okay, so what should be the elevation? So they are asking you the elevation. So basically they are asking this height. They are asking this height. What should be the elevation of the outer track with respect to the inner track? So this is the outer track, this is the inner track. Okay. Uh, if the width of the track is w, So I just write tan theta is equal to h upon w. So from here I will get the value of h as v square w upon rg. That's it. This is option number 1. Okay, let's proceed to the next question. Out of air and liquid, which substance is more viscous? So liquid generally has more viscosity than air. So you can say that there may be some exceptions, but in general liquid has more viscosity, or liquid is more viscous than air. Okay, so the answer is 2. Let's move to the next question. In this question, what is given to us? There is a metallic frame of the dimensions as shown here. The area vector is making an angle 60 degree with the external magnetic field, which is in this direction, and the magnitude of the magnetic field is 4 Tesla. The frame is taken out of the field in 10 seconds. That means there was flux initially and the flux will suddenly change. Then find the average EMF. So there's a printing mistake here. Okay, there is find the average EMF induced in the frame. Okay, so what is the average EMF? So average EMF basically will be delta phi upon delta t. Okay, now what is the initial flux? The initial flux will be B is 4 Tesla, area is 2.5 multiplied by 2 into the angle between area vector and the field vector is 60 degrees. So cos 60 degree is half, this two getting cancelled. So the initial flux is 10. What is the final flux? The final flux is the final flux is 0 because it has been taken out of the frame. Okay, so the flux final is 0. That means the change in flux is 10, and according to question, the change in flux, the frame was out of the field in 10 seconds. So that means the average EMF is 1 volt. The answer is 1. Okay, again I'm saying these are all memory based questions, so there may be some changes in the actual question paper. Okay, so please remember that. Now next question is, an electromagnetic wave is given as E equals 200 sine 1.5x t 1.5x sorry minus 4.5 into 10 raised to power 8 t is the electric field, and the unit also given in SI unit. If the electric uh, energy density is dash, we need to find this n. Okay, and they have asked us to use the epsilon naught value as 9 into 10 raised to power minus 12 in SI unit. Now it's a pretty straightforward formula that the energy density is half epsilon naught E naught square. So this is the value of E naught. So I will just write the values here. Half into epsilon naught is 9 into 10 raised to power minus 12 into E naught square is 200 into 200. Okay, so then what is the final answer? I will get 9 into 2 18, and this 1 2 cancelled. So I'll get 18 into 10 raised to the power minus 8. So that means the answer will be 2. Okay, now let's move to the next question. In this question, it is given that there is a meter bridge arrangement and the null point is as shown in the figure. What is the unknown resistance S? It's again a pretty straightforward question. We know that at null point it has to make a Wheatstone, because the null point means there is no current through this galvanometer. So I'll just write S upon 60. The condition of Wheatstone is 60 upon 100 minus 60 is 40. So I will get S is equal to 90. That's it. This is the answer. All right. Let's move to the next question. In this question, it is given that there particle is moving in one dimension. Its displacement time relation is S is equal to 2t square plus 5, and S is in meters and T is in second. That means they are in SI unit. Find the velocity at 1 second. So you just need to differentiate this, and as soon as I differentiate this displacement equation, I will get the velocity. So that will be equal to 4t, and at t equal to 1 second, the velocity will come out to be 4 meter per second. That's it. The answer is 4. Okay. Let's move to the next question. What is given here? A sphere of small size is at the bottom of a lake. The depth of the lake is given to us as 200 meters. due to the pressure, its fractional change in volume. They are asking what is the fractional change in volume due to the pressure that has been applied because it's inside the tube. So you know the excess pressure delta P is equal to rho gh, right? And I also know delta P is equal to magnitude wise B delta V by V, and they are asking the fractional change in volume. That means they are asking delta V by V. So delta V by V is nothing but delta P by B. Now delta P is rho gh, and the bulk modulus is given to us in the question, 5 into 10 raised to the power 12. So let's solve it. And rho is the density of water. Let's take it 1000 kg per meter cube. G is 10, h is 200 meters divided by 5 into 10 raised to the power 12. So 1, 2, 3, 4, 5, 6. So this will become 10 raised to the power 6. 2 by 5 into 10 raised to the power minus 6. Okay. So I need to find in terms of 10 raised to the power minus 7. So clearly you can see it is 4 into 10 raised to the power minus 7. So the answer will be alpha equals 4. Okay. Now let's move to the next question then. In this question, what is given? A ring has a uniformly distributed charge. Charge is also given 2 pi coulomb. The radius of the ring is 3 centimeter. A charge of this much coulomb is placed at the center of the ring. As soon as we place a charge, as soon as we place a charge at the center of the ring, every element of the ring starts to experience a force. So let's say this is the ring, and the ring already has a charge of 2 pi coulomb, and we have placed one charge here at the center of the ring. Then every element of the ring starts to experience an outward force. And if every element starts to experience an outward force, although the net force will be zero, but every element is experiencing an outward force to stretch. That means there is a tension developed in this ring. So they are asking what is the tension developed in the ring. Okay, to find the tension developed in the ring, what we can do is we can take a small element of the ring. So I'm drawing it big, but actually it is a small element of the ring, and the charge is placed at the center. And this ring is this ring element is experiencing a force due to this point charge q. Remember, it's a zoomed structure and zoomed diagram that I have drawn. Actually it's a very small element that I have taken from the ring. Okay, so due to this ring, the force will be in the radial direction. Okay, and that will be equal to k q dq divided by r square. This is the force df, and the tension here, let's say, is T, and from here also it is T, and let's say this angle is 2 theta, but remember theta is very small. Theta is very small. Okay, so now this angle is also theta, this angle is also theta. That means just a minute, that means this angle, if this angle is theta, this angle is also theta. So if this is t, that means this is t sine theta and this is t cos theta. T cos theta and here also t cos theta will cancel, and this t sine theta or 2t sine theta will balance the electrostatic force. So I will say, because the net force is 0, so I will say 2t sine theta has to be equal to kq dq divided by r square. Now what is dq? If 2 pi r total length, 2 pi r length has 2 pi coulomb charge, then unit length will have 2 pi by just 1 minute. So I will write it again. Here I'll write. So what I was discussing, that 2 pi r length is the total length of the ring, and 2 pi r length has 2 pi coulomb of charge. That means r into 2 theta length, r into 2 theta is the length of this element, will have how much charge? So it will be 2 pi by 2 pi r into 2 theta. 2 pi r cancel, that is 2r amount of charge we have in this element. Okay, sorry, not 2r, 2 theta, sorry. 2 theta amount of charge we have. So I will just put it here. I will write 2t, and sine theta is small, so sine theta is nearly equal to theta, equals k q dq is 2 theta divided by r square. So here what we will can do, theta theta will be cancelled, 2 will be cancelled. The tension developed is uh, kq by r square, and the value of q is this 10 raised to power minus 6 coulomb. So when I put the value of q here, I will easily get the tension developed as 7 Newton. Okay, let's proceed to the next question then. In this question, it is given that there are two slabs of same thickness and they are placed each over other. The refractive index are different, and they have given the values mu as 7 by 3 for the upper one, and the value of mu for the lower one is 5 by 3. Okay. They are asking you what is the apparent depth of the table surface when I look from the top. Okay, so you know that when the object is in the denser medium, the objects appear to be shifted up, right? And the apparent depth is by formula, if you remember, it is T by mu. Okay, but here there are two slabs, so I'll just write T1 by mu1 plus T2 by mu2. This is the apparent depth. So T1 and T2 both are 6. So 6 divided by 7 by 3 plus 6 divided by 5 by 3. Okay, so what should be the final answer? So it will be 18 upon 7 plus 18 upon 5. Okay, the nearest integer answer will be n equal to 6. Fine. Let's move to the